We plug what the y equals in for y in the other equation, right? You sophomores that weren't here yesterday, pay attention. So we got x squared, and then instead of the y squared, we're going to put x plus 2 in place of the y. Remember, you got to square it. Equals 20. So the x squared plus y squared equals 20 is the equation of what? What did we say those were yesterday when you had both x squared and y squared, Spencer? Yeah, those were circles. Okay? So it's tough to graph a circle on your calculator. It can be done, but it takes some extra work. Okay? So it's much easier just to do substitution. Okay, so we're substituting this line. This is a linear equation. Put y equals in for y, and then solving for x, and then we'll solve for y. All right, so here's the shortcut to square a binomial. Take the first term, the x, and square it. You take the two terms and multiply them. What's x times 2? 2x, but then you got to double that answer, or times 2. 2x times 2 is what? 4x. And then you square that second term. 2 squared is 4. Okay? So we have a quadratic equation now that we have to solve. We're going to set our equation equal to 0 and then use quadratic formula or factoring to solve it. You can use quadratic formula every time if you want, if you're good at that, and most of you are good at that. We got a 1 squared plus a 1 squared, so we got 2 squared plus 4x, and then I'm going to bring the 20 over by subtracting, so I get negative 16. Okay? So again, I like to factor if possible. This has a GCF of 2, so I get x squared plus 2x minus 8. Are there factors of negative 8? Multiple two numbers I multiply to get negative 8 that add to give me positive 2. Right, 4 and negative 2, right? So this will factor quicker. That's a little quicker than the quadratic formula. But again, if you don't like the factor, that's fine. Just put it in the quadratic formula. Your A would be 1, your B would be 2, and your C would be negative 8. You'll still get the same answer. All right, so in factored form, this is x plus 4 and x minus 2. So to finish up, we set our factors equal to 0. I can't set 2 equal to 0. That's not a true statement. If that was a 2x, then I would set it equal to, if I got a variable with it, I would set it equal to 0. So this one I would add to, and this other one I would subtract 4. So there's my two answers. Okay? So what's happening here, if I were to graph this, the line would go through the circle, and there's 2 points of intersection. All right? Am I finished, though, just knowing what the two x's are? No. I have to substitute in to find the two y's. All right? So if we look back up at the top here, y equals x plus 2. I'm going to do y equals negative 4 plus 2, and y equals 2 plus 2. So one of my answers when x is 2, y is 4. And my other answer when x is negative 4, y is negative 2. There's my 2 points, okay, of intersection. So that line would, like I said, go through that circle if we were to graph it. And those would be the 2 points of intersection. So that's what we learned yesterday with the circle ones. when you have an x squared and a y squared, we're going to use substitution to solve. And again, you could get 0 answers, just like the day before, 1 answer or 2 answers. This example, this warm-up, we had 2 answers. Okay? I forgot to give you guys, I had done the homework for you. Oh, that's the old one. That's yesterday's. I got to go back to today's. All right, here's the homework, right? When I graph this one, and again, 10 and 11 and 16 were night before stuff, just putting it in your calculator. All right, so when I sketch this graph real quick, here's what it looks like. One of them, the -9 one, we'll make this the red one. Look like this. All right, and the -1 look like this. Okay, this was -1 here, and this was -9. Do those two meet at all? Will they intersect as they keep going? No. So what's the answer to that? What do we say when they don't intersect at all? No solution, right? No real solution. Okay? The number 11, they're both squared. All right? Just like these, there's 2 parabolas. All right? So when we graph it, we had the red one, the x minus 2 squared, moved over just 2. So it was kind of like this. All right? And then the blue one, the negative x squared plus 4x minus 2, kind of looked like this. So we had these 2 points of intersection. Okay? So you hit your second trace for calculate, number 5 for intersect, and get your cursor close to this left one, and it'll give you 1, 1. And when you do second trace, calculate, for the calculate menu, number 5, and move your cursor over towards this right one, you'll get 3, 1 for the points of intersection. Okay? We'll just do 16 real quick also. All right? The line, we'll make that the red one. Oh, I guess I made it green. The green one looks like this. And then the parabola, we'll make it the blue one. And remember, on this one, you're going to have to get y by itself, right, for that parabola. Then you'll have a parabola that meets down here somewhere. There's a point of intersection here at 1, -7. Okay, so that's all calculator stuff. You guys got questions with your calculator? Okay, 14 and 15, you were supposed to use the substitution. All right, you're taking this and putting it there. You're taking this one and putting it there. All right, when you're done with 14, you've got 2 answers, 0, 7 and 7, 0. So the line goes through the circle. So there's 2 points of intersection. Right, for 15, you get 1 answer for -2. So the line is tangent to the circle. It only hits it in one spot. Do you need me to show any work for either one of those, 14 or 15? Sure. So I'm going to write x squared plus 7 minus x squared equals 49 when I plug it in. All right, doing my shortcut, when I square a binomial, you square the 7, you multiply those two together, which is negative 7x, and then double it, times 2, so that's negative 14x. And then negative x times negative x is still positive x squared. All right, get this quadratic equation equal to 0 so that we can try to solve it. So I got 2x squared, combining like terms, minus 14x. When I bring this 49 over to this 49, what happens? It's gone, yeah. So there's no c value, or by c value is 0 if you want to put plus 0 in there. That's okay, but you don't need to. All right, I would factor this because what's the GCF to solve it? What's the GCF between those two? 2x. And then I get x minus 7. So it factors real quick. But if you want to use a quadratic formula, that's fine. Put 2 in for A, negative 14 in for B, and 0 in for C. And it'll work out. So I just set them both equal to 0. 2x equals 0. I'm going to divide both sides by 2. What's 0 divided by 2? 0, right? And then x minus 7 equals 0. So again, you guys know you're going to add 7. So x is 7. All right, so there's two x values. So plug them in for the y. Remember, y equals 7 minus x. So when I put 0 in for x, what's 7 minus 0? Thanks, you guys. When I put 7 in for x, what's 7 minus 7? Yeah, nothing. So that's our two answers. Okay, so again, that line will go through that circle, so it'll hit it in two spots. Those 2 points, it intersects the circle. All right? Anything else on that homework? Okay. Today, we're graphing quadratic inequalities. Okay? Inequalities mean we got the less than, greater than stuff, right? Less than or greater than, less than or equal to, greater than or equal to. Okay, so a quadratic inequality of two variables x and y can be written in one of the following forms. The graph of any such inequality consists of all solutions, x and y, all points of the inequality. It says previously you graphed linear inequalities in two variables. You can use a similar procedure to graph quadratic inequalities in two variables. So, quick review, a linear inequality. Let's make one up. How about y is greater than 2x minus 2, let's say. How do I graph that line? What's my y-intercept? Negative 2. What's my slope? 2 over 1, right? So I go up 2 and over 1. Up 2 over 1. You guys remember how to graph a line, right? Yeah. Now, what you got to remember, though, if it's just greater than or just less than, you're going to have a dashed graph, a dashed parabola. All right? If you got the equal to, all right, you'll have a solid parabola, up or down. So let's go this way for that. All right? Could be up or down, depending on which value. What value tells us, Cindy, it's up or down our parabola? A, thank you. All right, a positive A value is going to open up, a negative A value is going to open down. Okay? So in this situation here, since it's just greater than, it's a dashed line. All right, in the inequalities, all right, you have to figure out which side to shade. There's a bunch of points on the graph that I could put in for x and y, and this would be greater than. Normally, greater than is above, and less than is below. I always use a test point. just to make sure. And the easiest test point is this one. As long as your line or your parabola is not including 0, 0. You have to pick a different point then. You don't want to pick a point that's on the graph. All right, if I put 0 in for y and 0 in for x, I get 0 is greater than negative 2. Is that true or false? It's true, right? 0 is bigger than negative 2. If it's true, you shade the side of that graph that the point is on. If the 0, 0 did not work, if it was a false statement, then you shade the side that the 0, 0 is not. That point that you pick is not in. Make sense? But normally, greater than's above and less than's below. Okay? But if you want to make sure, you can always pick a test point. All right? So that should have been a quick review on shading for linear ones. We're going to do the same thing with quadratic ones. Okay? Again, when the test point is a solution, shade the region of the plane that contains the point. When the test point is not a solution, shade the region that doesn't contain it, just like we did there. All right? So, to graph this, okay, I'll just graph it by hand, but there's another way you could do it, right? Wow. It jumped all the way down there. Look at that. All right. The way we first learned how to graph these, we started by finding the axis of symmetry, right? So, negative b over 2 times a is positive 2 divided by negative 2. So my axis of symmetry is x equals negative 1, right? So I'll just use this green one. There's my axis of symmetry. Okay? Does this open up or down? Down, right? So it's gonna, oops, that's not what I wanted. It opens down because my A was negative 1. All right, how do I find my vertex? Right, plug the negative 1 in for x, right? So what's negative 1 squared minus 2 times negative 1 minus 1? Well, we got a positive 1 plus 2 is 3 minus 1 is 2, right? So negative 1, 2 is my vertex. Okay, what's my y-intercept? Negative 1. Okay, so what is the reflection of that, or the mirror image of that? What point? Negative 2, negative 1, isn't it? Isn't it that one? Because it opens down, right? Right, AJ? It doesn't open up. Don't give me a point over here at 1, 2. Right? We know it opens down. Remember, our axis of symmetry goes right down the middle of it. Okay? So, looking at this, is my parabola dashed or solid? Dashed. Very good. Okay? Since it says less than, do I shade above it or below it? Below, right? So below it is inside here, right? So any point I pick in the highlighted area, the shaded area, and I plug it into the original problem, will be a true statement. If I pick any numbers outside of the shaded region and plug in for x and y, it won't be a true statement. Okay, so the graph is just a picture of all the answers. All the answers are what's in the shaded area. Does that make sense? Any questions? Again, if we wanted to make sure, all right, if that point, shade, I'd probably pick a point like -1, 0 here, that one there. If I put -1 in for x, we got what answer? 2, right? Is 0 less than 2? It is, right? So it's a true statement. I'm in the right area, right? If that was a false statement, I would have would have found out I shaded the wrong part. You follow? Yeah. Right, so if you want to make sure, you can always pick a point that's inside or outside your parabola and see if you get a true or false statement. If it's a true statement, you shade where that point is, that area. If it's a false statement, you shade the opposite area. Make sense? Mm-hmm. So you can always use a test point. But basically, less than's below, greater than's above. All right? Again, if you wanted to, we could use our calculator to do this, right? To do your graph. And I don't have a problem with that. Okay? So your y equals negative x squared minus 2x plus 15. All right? Then graph it. Now, I don't know if we'll be able to see it all. We can't see the whole thing because what's the y-intercept? 15, right? So, if we went by 2's on my picture here, on my y's, 2, 4, 6, 8, 10, 12, 14, 16. At 15, halfway between, there's my y-intercept, okay? I could try to figure out my vertex, or I could go to my table and probably figure out what the vertex is. I like to make it look symmetrical. So here's my table of values for some points. -1, 16 looks like my vertex. So here's another point here that is symmetric to my axis of symmetry, right? It's a little off. Okay? Now, is my graph dashed or solid? It's dashed again, right? So, okay? I could get a little better look if you want to put like 2, 7 in here. If I can go by, I'll go by 1s there, 2, 7. I'm a little bit, I went too far, didn't I? That wasn't symmetrical, was it? 3 to the right, so it should have been over here, right? 3 to the left. So it should be a little wider. I'm getting a little sloppy there. But where am I going to shade? It says greater than. Outside of it, right? Above it. Okay? So it'll be all this area. Okay, any points I pick out there will work when I plug them in. Any points that I pick inside somewhere, like 0, 0, it wouldn't work. Is 0, if I put 0 in for y and x, I get 0 is bigger than 15. Is that true or false? That's false, right? 0, 0 is on the inside, so I have to go on the outside. Cindy. For the vertex? Okay, we can check that. So for the axis of symmetry, it'd be negative b over 2 times a. So that's a positive 2 over negative 2. So we got that -1. Did you put -1 in for x? Yeah. Okay. So we got a negative of a -1 squared minus 2 times -1 plus 15. So remember, we do the squared first. So -1 times -1 is 1, but this negative outside makes it -1. Plus 2 would be 1, plus 15 would be 16. So I think what you put was instead, yeah, that you just made it negative or positive 1, didn't you? But that's good to check. All right. Questions so far? Making sense? All right. It says a system of quadratic inequalities is a set of 2 or more quadratic inequalities. All right. So we're doing 2 on the same graph. And all we're doing is the same thing and seeing where they overlap, where the shaded areas overlap. So you're just doing 2 graphs on one XY axis. All right. So if you want, we can put them both in the calculator. Since I already have an x squared there, I'm going to delete that negative, change that minus to a plus, and then -3. And then do the negative x squared plus 3, and then graph. Okay. So I'll do a quick sketch. The one that opens up, is it solid or dashed? I'll just do a quick sketch because we're running out of time. This bottom one was the one that opened up. Solid, right? It's about right here. Okay? We'll make that the red one. We'll make this the blue one. Okay, the blue one is the one that opens down. Okay? It should be moved over a little bit. Let me do that. All right, and then this one is about like this, right? Just from that picture. All right, so for the red one, where am I going to shade since it's greater than? Above or below? Above, right? So it would be inside here. You guys with me? And then for the blue one, it says less than, so which one was that? Inside, right? And below it, because it was less than. So where would those reds and blues overlap? In here, right? So all the points in that red-blue area would work in both inequalities. Any points outside of that area wouldn't work in both. That's what we're looking for. When they're both, you have 2 in one problem, you're going to see where the shaded areas overlap. That's your answer. Does that make sense? Questions? So just remember, you dash it. Oh, my blue one should have been dashed, right? You guys didn't correct me, did you? All right? So remember, that's part of it. Dash is solid. Greater than or equal to, less than or equal to, solid. Greater than or just less than dash. Okay? Greater than's above, less than's below, when you're shading. If you're not sure, plug in a point. If the point works, shade that area that the point's in. If the point doesn't work, shade outside that area. Make sense? Questions? All right. There's your homework.